Hello friends, Satyendra here, and in this video, let's understand UDF in detail. So let's understand the concept of UDF first. So the UDF or user defined feature is a group of feature which is repetitive in nature. That means you use this set of features again and again in your different models. So it is very time consuming when you create this set of features again and again. So in such cases, it is better to convert this set of feature as a UDF to reuse it again and again in different models, which makes our work easier and faster. Now this set of features can be created using copy and paste in the same model multiple times. But when you do this activity using UDF, you get some additional advantage. So in this tutorial, we will understand UDF in depth. We will understand different types of UDF based on the placement and based on the UDF creation. And to explain this, I have two different type of models with me. One is this part and another one is this part. So I'll use these two parts to explain UDF in detail. So let's get started. Now let's understand the type of UDF. So UDF can be classified based on UDF creation and based on UDF placement. Now based on UDF creation, we have two types. First one is standalone and second one is subordinate. And based on UDF placement, we have again two types. First one is by reference datum and second one is by on-surface coordinate system. Now let's understand the difference between these two based on the UDF placement. So first I will show you by on-surface coordinate system. So this is an example of on-surface coordinate system. Here you get a drag handle for positioning your UDF. Then the second one is by reference datum. Now here you don't get any drag handle to position it. You need to select datum reference manually to position your UDF. Now you can clearly understand the difference between on-surface coordinate system and by reference datum. So in reference datum you don't get drag handles for positioning. So sometimes it is very confusing to select the reference. But if you go with on-surface coordinate system, then you get drag handles to position your UDF. So this was the difference based on UDF placement. Now the next one is the difference based on the UDF creation. So when you go to tools, UDF library, you get these options. You can create UDF, you can modify UDF, you can see all the UDF. So when you click on create, it asks you to specify the UDF name. I will just type a random name. Then you get two options, which is standalone and subordinate. So when you create your UDF using subordinate, your UDF will be linked with parent part. So whenever you do any changes in your parent part, your UDF will update automatically. But when you create your UDF using standalone, it will never update if any changes is happening with parent part. So both the options are having their own advantage and disadvantage. I prefer standalone because I don't want to update my existing UDF as the parent part changes. Now let's see two different type of UDF based on surface coordinate system. So both will have drag handle, but there is a small difference between them. Now if you see this UDF, the placement is from the bottom surface. So these features are moving from bottom to top. Now this UDF is from top to bottom. So now you can see that all the features are moving downwards. I have two drag handles, but the positioning is from top to bottom. So these two UDF both are on surface coordinate system, but this UDF is from bottom to top and this UDF is from top to bottom. So both are having their own advantage. So this kind of UDF can be useful for this kind of curvy surface. If I drag this here, since I have placed from this top surface, it will generate in all kind of curvature, you see. But if I place this UDF here, it will not regenerate because the UDF positioning requires a flat surface. So if your UDF positioning is from the bottom, then you require a flat surface at the bottom, and if your UDF positioning is from the top, then you require a flat surface at the top. And since you don't have any flat surface here, you cannot regenerate. If I move from this surface to this surface, you see, now this UDF got moved to the next surface. So these kind of UDF can be placed either on flat surface or on curved surface, because the placement reference is flat here, but this kind of UDF requires a predefined flat surface for placement. So you need to take care of the placement surface. Now let's see another model. Now if you see this model, I have one small UDF placed here. This is for screwing this plate. So if I place the UDF somewhere here, it will come like this. Again, this is also on surface coordinate system. So I have these two drag handles. So now you can see that this feature got placed. Now whenever you place a UDF, it will form a group which will look like this in your model tree. If you expand it, you will have all the features listed here. So this particular UDF is having these many features. Now let's create this UDF once again to understand the complete procedure. And for that, I'll just delete this. So in this tutorial, I will create UDF based on surface coordinate system, and I will explain the complete procedure. So I'll first delete these features. Now to create UDF based on surface coordinate system, there are few conditions. And the first condition is the first feature of this UDF will be a coordinate system. So I will create a coordinate system. I will select the surface to place this coordinate system. Now flip the X direction. Say OK. Now your coordinate system is created. Now you need to create 3 datums which will only have this reference. So create a datum plane. Select this coordinate system. Now this is my right plane. So I will write RP. Again go for datum plane. Select the same coordinate system. Select Y. This is my front plane, so I will write FP. Once again go for datum plane. Select the same coordinate system. change to Z, and this is my top plane, so I will write TP. So I have created 3 datum planes and 1 coordinate system. Now these 3 datum planes are dependent on this coordinate system, and the coordinate system is dependent on this model. Only the coordinate system is having external reference, other 3 datums are having internal reference. So this is the first condition. Now you create all the UDF features using these references. You should not select any references out of these references. So this is the second condition. So I'll go with extrude. I cannot select this surface. To create this extrude, I need to go with top plane. Now create the circle. This is 2.5. Say OK. Move it down. The thickness is 1. Say OK. The next feature is the hole. I will select this one, and again I cannot select this surface. I need to select top plane, make it through all, say OK. Then the last feature is round. You should not select edge like this. You should go for intent selection. So move your cursor near this edge, right click, and now you can select. So now your feature is ready. So now you have these many features to convert into UDF. Now let's convert into UDF. Now this UDF is going to be standalone on surface coordinate system UDF. So to create UDF, go to tools, UDF library, create, name the UDF. I will write screw hole. Now here you have 2 options, standalone and subordinate. Once again I will tell you the difference. If you create UDF using subordinate, then if you do any changes in your parent part, then your UDF will update. That means there is a link between your UDF and parent part. But if you go with standalone, it will not update. So there is no link between UDF and parent part once UDF is created. So I'll go with standalone, done. Now it is asking you, do you want to include reference part? No. Now you have a set of options to be defined. So first you need to select all the features. Select from this coordinate system to the end of this. Say OK, done, and done. Now it is asking you to enter the prompt for placement. It is for easy understanding, but I will just bypass it. Now the next option is variable element. If you have any feature to be vary in this UDF, you can select that. You have variable dimensions. If you want to vary any dimension from this feature, then you can select it. Suppose I want to vary this height, then I can select this dimension and I can say enter. So now it is defined. Another step, you have family table. If the parent part is having family table, then you can use that family table with this option. So now I will say OK and done. So now my UDF is created. Now I can delete these features. Now let us place that UDF. Go to model, user defined feature, and now you have just created screw hole. Double click this, say OK, and just select the surface. It has come. Now you place it using this drag handle. So on surface coordinate system UDF is better than by reference datum UDF because it gives you the drag handle to position it, but in by reference datum the placement is very confusing. You need to see the text prompt to understand the placement reference. Now I'll say OK, and your UDF is placed. So this was the complete idea to create a UDF based on surface coordinate system. I explained all the conditions. Now let's have a small break. And meanwhile, you can like this video and subscribe my channel. Thank you. Now let's understand the on surface coordinate system UDF based on the top surface placement and the bottom surface placement. And for that, I will open a couple of models here. So this is one model. Now if you see the model tree, it is created using this coordinate system. So this coordinate system is the first feature, and other three planes are dependent on that coordinate system. Then I have extrude. Now if you edit this feature, you will see that this is going from bottom to top. Once you have created the coordinate system, you added three planes, and then you created this feature which is going from bottom to top. Again, when you create this feature, you should not take this surface as reference. You need to take the top plane. So to create this feature, you need to use only these references. Then the draft, if I edit this, the draft is also created using these references. Then I have pattern, which is nothing but the rib. Now when you create the rib, this reference, and this reference, these all are taken from these references. So you should not select any reference out of this. Once one rib is created, you can pattern it. Then the last feature is the whole feature. So again, the whole feature is having top surface as a reference and the center axis as a reference, which is part of this feature. So this is acceptable. Now once you create these features, you can convert it into standalone or subordinate UDF. So this is from bottom to top. Now if I open this one, this is from top to bottom. So here also, this is the first feature. So if you see, I have selected this top surface to place this coordinate system. So if I drag it up, this coordinate system is done. Now I'll just hide these references to make it more clear. Now if I drag it down, this is the right, which is again created with this coordinate system. Then the top, if I edit this, taken from the same coordinate system. And if I go for front, taken from the same coordinate system. Then the first feature, extrude, edit it. If I go for sketch, now you see, if I go for reference, this is a coordinate system taken as a reference. You can select the datum planes also, this datum planes. Once this is done, you should not give any numerical value, or you should not go with select reference, just go with extrude up to next surface. So automatically it will move to any surface, doesn't matter it is flat or it is a curve. Then the draft, so if I edit this, you can see that the draft surface is from this extrude and the top surface is the reference. Then the rib plane, you need to create the rib from the top. So this plane is also created using these references. I have taken top plane as a reference, which is this plane. This plane is created. Now the rib created like this. Once that is done, then add the draft and then the round. Once pattern is done, then the last feature is the hole feature. So if I edit this, this is my hole, which is having counter bore, and this is the standard hole M5. So once you have completed all the features, convert it into UDF. And for that, go to Tools, UDF Library, Create, write down the UDF name. I will go with standalone, done, no, select all the features from here till here, say done, done and done. Enter, 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 and then you can add other stuff. I'll just say OK, done. So my UDF is created. I'll just close this, and here I will place that. So to place that, I'll go to user defined feature. Now I've just created this UDF, both top to bottom. Double click it, enter, select the surface. Now you cannot select a bottom surface because it is top to bottom. You need to select top surface. Now you can drag it here and there. You can place it anywhere you want. Just use these two drag handles to position it, and you can say OK. Now here you have a lot of options. If you go to options, you have these features listed here. So if you want to modify any feature, you can modify from here. So suppose I want to modify this pattern. I will select this feature and I will go for edit definition. Now here, suppose I want to increase this number of ribs, then I will go for 5, 360, and you see, say OK, and you can say OK. So similarly, you can edit all the features available here, and your UDF is placed. So once you placed your UDF and still you want to modify some of the features, then you can go to your model tree anytime, expand it, and you can modify your features. You can do changes in your existing features. Now the best part of UDF is when you place a set of features using UDF, you can anytime replace it with another UDF. Go to replace, manually retrieve UDF. If you are replacing your UDF with family table, then you can go for family table. Otherwise, you can go with manually retrieve UDF. Say OK. I will just select M12T and I'll say open. Say OK. Say OK. So your existing UDF got replaced with another UDF. Now to move this UDF after placement, go to your model tree, expand it, and edit your coordinate system. Move it from your old location to a new location. Say OK, and your UDF got moved. So this was all about UDF, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.